is a function? Here we go. Actually, just before I start, does anyone know or remember, because we did a touch base on it last year on year 11 stuff.
Draw a line and pass the next function.
Well, that is how, but I don't like that. When I teach you guys, I want you to know exactly why it makes sense. That is a shortcut to knowing why it's a function. It's called a vertical line test. You just draw it down, and therefore it works. But if I ask you why do we draw it down? Why can't I draw it diagonally? Can I draw it like sort of diagonally down? Does that work too? How do you know that? So I don't want you to be robots, I want you to think, yeah? So the definition of function, this is what I want you to know. What is a function? First you have to understand the term, what is a relation? Because that's the two differences. A way to describe it is a relation is the bigger picture, and a function is a small picture of a relation, okay? So first thing is, what is a relation? It's very easy. Relation is a set or group of coordinates, and hence relationship. Yeah, relationship is relates between two things, or three things, or four things. In this case, we normally talk about coordinates that are based on two variables, right? You can have three variables and onwards, but a relation just means that it's got a group of these things. Now, these things, you could have multiple variables in there. So, if that is true, that is a relation. You can pick any coordinates you want. You can make it up right now, and that is a relation. If you just thought of any random coordinates that you collect together, that is called a relation. So I just picked out 0, 1, 2, -2, 3, 4, 71, and -2. I could have put a 0, a million there if I wanted to, and that would just be a set of coordinates. A set of coordinates is called a relation. Okay, so if it's not a function, it's a relation. That's how simple it is. So if that's a relation, then why do we need to know what a function is, right? A relation just means a group of coordinates, but this is when they realized that certain coordinates, that the way you put it, has a certain pattern. And then they started defining what these patterns are. And the patterns that you've learned so far, linear function, quadratic function, a square root function, but you can also have square root relation, which is something I'll talk about later. Okay, but that's the point. So the idea is that function just happens to be, fits a certain category, and it fulfills certain criteria, and we're like, cool, we call those functions now. So what is a function? I like to think of it as, the definition of function is that for every x coordinate, there is a unique meaning special, and there's only one y value, one y coordinate. That's the relationship, that every time you put an x in, it doesn't matter. And I'm going to illustrate it to you so that it makes sense. If this is my box, that's my machine, my function, and the function that we all know, y equals x squared. So this is my x squared, all right? What you do is we pick a domain. We always say whatever x is, you're going to square that, right? So what I'm putting in here is your domain. So let's say I said x was equal to 4. If I chuck 4 into this machine, it will tell me what y is, which is my range. That's how you get a coordinate. You put a 4 in. What does it do? The function squares it, and you square it and you get a value, right? Now, let's think about it. If I put a 4 in and I square it, what do I get out? 16. So you would say that when I put a 4, I get a 16. Yes.
Is the y coordinate unique in the block? Because you have to, you're not 16 twice.
No. So this is the confusion. So when I draw this picture, that's a very good point. That's why I picked a quadratic first. It is unique. But what is unique? Why? You said there's 2 of them, but let's label out the coordinates.
Oh, okay. So but you're talking about the whole coordinate, not just the y part.
Just the y part.
Yeah.
The y part is special in the sense that there is no other 16s except for just the 16. The 16 is only available there. Yeah. But there is no double 16s where the x's are different. Yeah. So what I'm trying to say is when you put a 4 in, you will get only one answer out. There's not going to be 2 answers. There's only going to be one answer. So if you're only going to get one answer, that's unique. When you get multiple answers for the one value, that is not a function. That's the definition. Definition of a function is that they just said, oh, hey, we just realized that whatever x is, as long as I only get one unique, meaning only one thing that spits out, I don't care what I put in. I can jam 20 coordinates in, but as long as you spit out one product, that's great. I only want one product. I don't want multiple ones. I just want one. Okay? If I get only one product, That's a function. So, even if I chuck in, say if the coordinates was 4, 16, if I chuck in x equals to -4, it still gives me only one result, which is 16. Okay, so -4 gives me 16. This is still a function because it still fits in the criteria I just said. The criteria is as long as it spits out one type. But the very interesting thing is that there is two y values here. And that's why we split that into a different name now. And you learned that last year there were 4 types of function, 4 types of relations in general, 2 of which is a function. And you want to remember those types. You got a one-to-one, and one-to-many, many-to-many, and many-to-one. Just switch them all around. So one-to-one, one-to-many, many-to-one, many-to-many. Yeah? Those are the 4. But which one is a function? I just said 4, so I'm going to write it out. You had one-to-one, many-to-one. Sorry, that's very bad spelling there. Many-to-many. Many-to-many, and then what am I missing? One-to-many. You got 4 types. Which of these 4 is a function? Anyone know? Why is it the top 2? Perfect. The beautiful thing that is the language we use to describe the relations, we specifically said x is first and then y. Even your coordinates, it's x first before y. Even your alphabet, it's x before y. So when we write out one-to-one, what it's actually saying is there's only one thing that you're putting into the machine, and your result is you're only getting one result. So hence, what you're putting in is your x, next one's your y. So what is this saying? Many x's, and you get the same one result, which is essentially what this is. You put a 4 in, you get a 16. You put a -4, you get a 16. They both have the same result, but different x's. Okay? So whilst it's still a function, because you only got one y value, because that's the definition of function. The definition said, I only want one product. I don't want many products. These aren't functions. These are relations. This is a problem. I don't want many products. I just want one. Just give me one. One's enough. Too many is too difficult. So I just want one. So that's why a one-to-one is a function. Many x's, when you put it in, it becomes a quadratic function. But it's a type of function. It is a many-to-one function. Okay? Whereas one-to-one, what would be an example of a one-to-one where you put 1 in, and you don't get any other extra y's, you only just get one y, and even if you put any other x's, you're never going to get that y. It's a unique pair. Which one's linear? So if you draw out a linear equation, which I'll just do, so I'll draw the graph so you can see as well. Here we go. If I draw a linear equation, see, for every x coordinate, if x was 2, the y value, if the equation of the machine was y equals x, then this is also 2. So you got 2, 2. Those 2, I'm using 2's in those 2. These coordinates are unique. There's nowhere else on the graph where you're going to have y equals 2. It's only matched with 2. They're faithful with one another. It's just 2 and 2. Nothing else. Whereas a quadratic, quadratic's different. So a quadratic equation means that if I had a 4, and this was a y equals x squared, that means 4 is in a relationship with 2, as well as it's in a relationship with -2. You've got 2 coordinates here where you get the same y value. 4 is cheating, yes. It's a many-to-one relationship. But this is called a function because you're only having one y value. In the function, there's only one 4. You can have many x's if you want, but you can only have one 4. So this is a many-to-one function. That's a one-to-one function. Yes? Good. Very good. And that's where we're trying to get to. So the whole end of this session, that's what I want you to think about. Okay? So very good question. So I just highlighted this is one-to-one. This is a many-to-one. So how do you highlight a many-to-many? What can you think of right now where not only the y's cheat on the x's, but the x's also cheat on the y's? Circular. That was the one function, or not even a function, it was a relation. It's a circle relation. That's why when you learnt in year 11, what were you actually doing? You learnt half circles. Because half circles don't cheat. Oh, actually, that does cheat. It's a many to one. But the y's don't cheat with the x. Oh, sorry, the x's don't cheat with the y's, right? Whereas if you do a full circle, see, one x is paired up with two y values, and one y is paired up with two x values. So one y is paired up with two x values. There are two x values for that coordinate, and for this point, one x coordinate has two y values. That's a many to many. Everyone's cheating on everyone, right?
Is that a function?
That's a relation.
So you're meant to you find the meant to many function.
No. Very good. Okay, so that's why when you that's a very good point. I like what you guys are now thinking about. So it shows me that you are learning what I'm telling you, because that's what the examiner is going to do. They're going to give you a relation, and they'll say restrict the domain such that this is a one-to-one function or a many-to-one function. So you have to understand what a function is. You need to know how to use your set notations so that you could then say, well, how do I make it a one-to-one or a many-to-one? Because you're right, this is a relation. But if I want to make this a function of any sort, what would I have to do? Okay, so for it to be a function, I'd have to somehow remove the range, not the domain. If I can say that don't include 0 to negative infinity, this is a function. Now it becomes a many-to-one. It's like an inverted parabola. Okay, so that becomes a function. But that's essentially what the skill is, that you're going to be given a relation, and your job is to make it, restrict the domain or range so that you get a function. But what type of function?
So why are they called circular functions?
Circular function is different.
Is it like unit circle? Yeah, is that a circular function?
Circular function is the sine cos tan. So you get a sine function, which is an angle relationship with the distance around it. So that's why. But when you're thinking of
your actual sine graph will be a circular function, but the unit circle itself is a circular function.
Yes, yeah, because the sine graph is a many to one. It goes up and goes back down and oscillates. That's a good question. So you're thinking.
Yeah.
So you're thinking about the things that you've learnt in the past and tying it into now, right? So that's what year 12 is about. It's about clarifying what you understood beforehand and ironing it out. Okay, that's important.
It says functions always have unique x coordinates.
What do you mean by unique x coordinates?
As in, like, if it won't come again, like if you did another y value, like the one to there's like this one is I have a y coordinate that has y coordinate that has two coordinates.
Yeah. So what's unique here is the 4. There's only one 4, but there are two x's. That's why we say many x's to the one y. Yeah. Whereas this one, for one x, they only get one y, and that's uniquely special. There's only one faithful x to one faithful y. There's no other ones there. But what makes it a function is as long as you only get one y, one product of y. Yeah. So that's a very good point. I'm going to show you a relation where it isn't a function, okay? And then it will make sense there. Okay. All right. Just to tie it up as well, I know some of you are starting to now think, and you're getting a bit confused between the repetition of y and repetition of x. How is it a function and how is it a relation, right? So I've shown you what a one-to-one looks like. I've also shown you what a many-to-one looks like, and I was harping on about the y's need to be only one product. So let's find one where it is not one product, okay? Let's have a look. I'll give you an example, all right? Let's say this is my machine, and a classic example, the easiest one to do, is a square root function, okay? Oh, sorry, not square root function, square root relation. Now remember, when I square root a 9, if I put a 9 in, if x was equal to 9, what is the answer again? 3, but not just 3. Plus and minus 3, remember that? When you were doing your algebraic solving, if I gave you x squared plus 4, oh sorry, not plus 4, minus 4, and I said that was equal to 0, and I said solve for x. Remember back in year 10 and year 11? If I told you to solve this, what you would have done is add 4 and square root 4. But the answer is not just 2.
If your graph is like y square root x, then isn't the root already positive? So if you would have put in...
That's why I fixed my language and I said square root function, and then I changed it to square root relation. And that's going to be key.
That is a square root relation. Whereas if get y equals 3x, that's the square root of
Oh, I see what you're trying to say. Yes. Yes. So if I gave you y equals to root x without saying anything else, that is a function.
Okay.
And that's because it's assumed that it's a positive.
values for y.
Yeah. And that's, yes, exactly. So let's have a look at this one. And this is where I want you to think about. Last year, when you learned square roots, when you square rooted the graph, this is what the square root graph or function looks like. That's your square root function. And that's what your root x looks like. That's what you did last year. But what you have to realize here, listening, when you square root the 9, when x is 9, y is 3, and you were correct. But you also have to remember that when you square root, if we didn't take in consideration that this was a positive root, because remember, when you square root, you can have a positive answer and a negative answer. It's like saying negative 3 squared is 9, and 3 squared is 9. So when you square root 9, it should give you either one of these two. But funny enough, last year when you sketched, you only sketched one of them, right? That's why we call this a square root function. But if they said square root relation, it means that you can have two answers. You don't have to have one answer. So if I drew out the machine, when I put a 9 in, a function would mean you only get one of them. And how do you know if it's a 3 or a negative 3? It depends on the sign of the square root. If there's a positive or a negative. Now, positive, we never write the positive in front. That's why we assume square root is a positive root. If you want a negative, put a negative in front, and it becomes a negative root. That's why last year, you learned that if you had, if you put in negative root x, it becomes x-axis reflection. That's why it reflects, and you said it looks like this. But technically, when you square root, it should be both plus and minus, and it looks like this. Now, what does that remind you of? Very good. And it makes sense. Why is it a sideways parabola? Because square roots are inverses of squared parabolas. Squared and square roots. That's why they're inverses, and then they will be mirrored. And that's another thing. That's why I said, if you don't understand functions, then when we get to inverse functions, it has no sense to you. It doesn't make sense there. It makes sense that squared and square root, I'm just going to tangent a bit just so you can see what I mean. Can I get a show of hands who've learnt inverse functions last year? How to find inverses. Okay, I'm just going to do a little bit here. You don't have to understand this, okay? When you're doing inverses, the technique, and I'm not going to explain it, I'm just going to say the technique, is that you switch the x and y's, right? You switch the x and y's, and you rearrange to get the y by itself. Now, this is the original function. The inverse function is when you get rid of the squared, this now becomes root x. This is your inverse function. So how do you get your inverse function? Switch the x and y's and solve for y, get root x. Now, if you actually sketch the graph, this is what this looks like. If you sketch this, it actually looks like this. But why does that happen? And that's where I want you to understand what a function is first before we can even talk about the theory of it. When you switch the x and y's, you're really just saying y equals x and x equals y. So what you're saying is there is this condition, y equals x. And what does y equals x look like? I'm going to do a little, it's a straight line, and it looks like that. This is the y equals x line by that mirror, and so that's why everything here gets reflected along that mirror. Not on the x-axis anymore, not on the y-axis, it's mirrored on the y equals x. That's why if you mirror this image here from here to here, if I mirror it, it looks like this. If I want to mirror this side, see, I'm just copying. If that goes up, then it goes on the side. And that ends up being your sort of, I'm doing it badly, but it's meant to look like that. That's where it's coming from. See, whatever this is going there, then it's going here. That's your bottom part. Okay? That's why there's a square root relation. But why is this not a function? Going back to what Matthew said, if you draw a vertical line, and it crosses once, it's a function. If you draw a vertical line, it's not. But why was it a vertical line? That was my first question, wasn't it? I said, why do you have to do a vertical line? What if I did a horizontal line? I mean, a diagonal line. Does that work? Right? It's not because I taught you that, not because I tell you so. It's because it goes back to the definition. What was the definition? As long as you get one product. It doesn't matter how many x's you put in, as long as it goes out as one y value. So let's have a look. Why do we do a vertical line? Because the vertical line represents putting only one x. If you put one x into the machine, you want to see if you get two y values or not. That's what you're testing. You're testing, if I put in 1x, do I get 2 y's, because if as soon as you get 2 answers out of it, it's not a function. It is now a relation. That's why you do a vertical line test, because you're assuming vertical line at x equals 1, this is where x equals 1. You're putting only one variable in, and you want to see if you're going to get 2 variables, only 1 variable. So when you do a vertical line test here, what it actually shows you is you get two coordinates for the value of 1. So that means if you put 1x in, you're going to get 2 y's. That's why this is called a square root relation. Whereas the quadratic, why is that called a quadratic function? When I do the vertical line, it makes sense because when I choose one x value, I get that one y value at that point. It's not to say that I don't have another y value. It doesn't matter because we don't care. We only care that at this point, when I put an x, I only get one product. That's what we want. We just want one product. And that's what the definition of a function is. That's why we do a vertical line test. Yeah?
Is one too many of them?
One too many? Is it a one too many? No, this is a one too many. So one x value to too many values. To two y values or many y values. Okay, so what I've just illustrated here, a square root relation is an example of a one to many. One x to two y's. Yep. Very good. All right, that was exactly what I wanted to finish on. Last question, guys. We had a vertical line test, and I want you to sit on this when you get home. Vertical line test because for 1x, you just want to see if you're going to get 2 y values. You don't want 2 products, you only want 1. That's why vertical line is for function. Then what is horizontal line testing? What am I testing here now? So if you think about it logically based on definition, when I draw a line across, it means I only have one y. If I have 2 intersections, what does that imply? Many x's to the one y. But if I don't have many x's, if it only crosses once, then it becomes a 1 to 1. So essentially, what does a horizontal line do? It tells you whether it's a many to 1 or a 1 to 1. But what is a many to 1 and what's a 1 to 1? It's a function. So essentially, you're just asking what type of function is it. A horizontal line test just tells you, is it a many to 1 or is it a 1 to 1 function? Okay, vertical line test shows you, is it a function or not? If it goes down and crosses once, it's a function. But if it crosses twice, you've got 2 products. It's a relation now. Your horizontal line test tells you what type of function you have. Okay, now I want you to sit on that. Like I said, it's a big idea. I'm all about foundation. You get the foundation right, everything else flows. Okay, so really sit on that and think about it. Because 1C, we're going back to this idea again. Okay, so think about it over the weekend. Second one. Yep, so many to many, you see, like, if I did a circle, right? And I want to see if it's a function. So for 1x, do I get 2 y values? Yes, I do. That's a problem. Yeah. So if I did a vertical line test, I'd say not a function. Okay, so it's a relation. But then what type of relation is it? So now I do a horizontal line test, and you can see that not only that it crossed twice for the y values, it also crossed twice for the x values. That's what. No, not for relation. Relation is usually because you're interested in whether it's a function or not. So yeah, but I'm just doing the horizontal so we can see it's many to many and many to many, both from both sides. Whereas, just to finish off on what you were asking there, if I had a square root relation, for example, and I did a vertical line test, it's not a function, okay? But then if I do a horizontal line test, then it only crosses once. So now you know it's only 1 to many, not to 1. Because 1 to 1 means that you only have, it's a function, yeah? But it's not a function. Okay. Yeah, just sit on it. Really think about it. Yeah.
When do you not teach classes? Like this?